Fat and oil has the highest amount of energy when taken in, but yeah, we were told that carbohydrates has a lot of energy. Carbohydrates and energy giving food and all those stuff. But do you know that fat and oil has more energy than carbohydrates? So here is the reason. Let me tell you the reason. So if you take in fat and oil, and if you take in carbohydrates, fat and oil actually has a lot of energy and has more energy than when you take in carbohydrates. Do you know that? Like if you take in let's say butter, say fat and oil, let's say lipids, it produces more energy than when you take in rice, yam, etc. So in this video I'm going to show you a lot of things, but the main topic of today is going to be what roles and function of a cell. So stay to the end as I show you more details about the roles and functions of the cell. Let's go. And now the first one is growth. What actually is growth? Growth is the increase in size of an organism or increase in biomass. And growth is an anabolic process. When I say anabolic, here is what I mean. Anabolic process is process that involves what? Building up, joining together. And catabolic means what? Breaking down. It's as simple as that. There is nothing big here, okay? So anabolic process is what? Building up, when you join something together. You know, if you don't put many processes together, you'll not be able to grow. That is why growth is what? An anabolic process. It's as simple as that. So growth is an anabolic process, and there is another process known as what? Catabolic. So guess that. Breaking down, right? Yes. So there is anabolic and catabolic process, where anabolic process means what? Building up, and catabolic process, which means what? Breaking down. And now growth has 3 different stages, okay, which is cell division, cell elongation, and cell differentiation. You can call the cell differentiation cell maturity. So the first one that we're going to look at now is the cell division. What actually is cell division? So cell division involves mitosis. Mitosis is an asexual way of reproduction, and it's not normally found in humans, okay? We don't undergo mitosis. Like I said, it's an asexual mode of reproduction. You know, we as humans, we undergo sexual mode of reproduction. So cell division is the kind of division that happens during the growth of an organism. So like you know, we as humans, we don't undergo mitosis, we undergo what? Meiosis. I'm going to come to that part, okay? Just hold on, okay? So cell division occurs when an organism is growing, like all those organisms that undergo asexual mode of reproduction, like the budding type, the yeast mode of reproduction, all those types. So during asexual reproduction, mitosis occur, and under mitosis you see the cell division. So this cell division occur during when an organism is what? Growing, and maybe what they call it, developing. When an organism is growing and developing, and it involves what? Diploid number of chromosomes. I hope you guys have not forget what I said diploid actually means. Diploid is what? 2. Haploid is 1. Okay, so it involves what? Diploid number of chromosome, which is 2n. Will not give you what? 2n also. 2n to 2n. That's 2 times the number of chromosome. That's what the n represents. So 2 times the number of the chromosome now give you what? The diploid number of chromosome. And humans have what? 46 chromosomes. So that's just it though. And you know, this division is actually dividing to what? Produce other cells. And I'm going to give you the stages at which what? They produce. Now let's talk about mitosis. What is mitosis? Mitosis is also known as replicative what? Reproduction. Replicative. When I say replicative, you see the name replicates. Or okay, let's use the simple one. Duplicative what? Reproduction. What is mitosis? Mitosis is the process whereby organism duplicates asexually into different what? Daughter cells. You know, I said duplication is when you scatter something into what? Many parts. When you make one particular thing very many. So mitosis is the process whereby an organism carry out asexual mode of reproduction. So mitosis is the process whereby organism reproduce asexually by duplicating itself into different daughter cells, or let's say 2 identical daughter cells. So let's look at the stages of mitosis. The number 1 stage is what? Interphase. Okay, let's use let's use a mnemonic called IPMAT. IPMAT. That's the mnemonic for all the stages of mitosis division, or let's say mitosis reproduction. Is that not interesting? You see, I've given you the mnemonic that you'll be able to use to remember. So the first one in that IPMAT is what? Interphase. What actually is interphase? The interphase is the resting stage. Come. So let's say interphase is what? The resting stage. What is the resting stage? Resting stage is the stage whereby the organism is planning to what? Undergo cell division. Like if you are resting, you are not doing anything. You'll be planning about something, or you'll be thinking of the way forward, right? Yes, you'll be thinking of the way forward. Yes. So interphase is what? The resting stage. That's when the organism is planning to undergo this what? Cell division. It's as simple as that. So let's move on to the next one, which is the what? Prophase. Or the prophase. What actually happened in the prophase stage? So here's what happened in the prophase stage. The chromosome will become thickened and shortened. Listen carefully, the chromosome will become what? Thickened and shortened, and form chromatid, which is what? Joined together by the what? Centromere. So here's one question. Chromatids are joined together by what? The what? Like 2 chromatids are joined together by what? Centromere. Did you see that? I've just given you one question, one bonus question. So the chromatids are joined together by what? The centromere. And the centrioles begin to what? They begin to separate. Yes, they begin to separate. So in the prophase stage, the chromosome begin to what? Thicken and shorten. Do you see that there? Do you see that? That short chromosome that form the chromatid and joined together by what? The centromere. You see it there in the diagram, abi? Yes. So now let's move to the next one, which is what? Metaphase. You know, I give you a mnemonic, which is IPMAT. So the next one is what? Metaphase. So in the metaphase stage, it begins to disappear. Oh my God, it begins to disappear. Where did this went to? Where did it went to? We don't know. But let me tell you, and I know where it went to. So it went to the center. It began to what? Align at the what? Equator. It went to the center and align at the equator. Yes. And it was joined together by what? I told you now. I've told you before. The centromere, yes. So it went to the center and was joined together by what? The centromere, with the help of the centromere. Without those centromere, they will not be able to stay together. They are stubborn guys. They will not be able to stay together. So they went to the center and was joined together by what? The centromere, as you can see in the diagram. As you can see there. Yes, they went to the center and joined together at the equator. Let's say the equator. I don't want to call it the center. It went to the equator and joined together. That's what the metaphase stage is all about, though. So the next one is what? Just guess it now. So when I say IPMAT, it's anaphase. Yes. So what happens in the anaphase stage. Now in the anaphase stage, here is what happens. So the spindle fiber begin to what? Move to the center, to the sides. Look at it there. Look at it in the diagram above. The spindle fiber begin to what? Move to the sides. So that's to show you that there is something dragging in there, Abi. It's the spindle fiber. It's because of the contraction of what? The spindle fiber. So the spindle fiber will now shift it to the sides. So the chromatids go to what? The side of the division process, and it's because of the attraction, or let's say the contraction of the spindle fiber. The spindle fiber don't want it there, so it begins to pull it to the side. That's what happened in the anaphase stage. Okay, now let's look at the telophase stage. What actually happens there? Come, let me tell you. In the telophase stage, the cells begin to divide into two daughter cells. That is where the division, that's the final process of it. It divides into what? Two identical daughter cells. Yes, that's what the telophase stage is all about. So let's move on to the next one. Now let's look at how we can actually measure this growth. The first one is what do you call it? Length, mass, volume, area, width, breadth. You know all that now. Even mathematics student, if you are a mathematics student and you're watching this video, you are supposed to know that. So you can measure a particular thing with all those things: length, mass, volume, area, breadth, and all that. Now we're going to look at growth curve, and growth curve is normally called what? The sigmoid curve. Listen carefully. Growth curve is normally called the sigmoid curve, and there are two types of growth, which is allometric and isometric growth. Now, what is allometric growth? Allometric growth is the type of growth where all the growth processes do not occur in what? The same rate. Then isometric occur in what? The same rate. So allometric occur in different rates, and isometric occur in what? The same rates. So the growth process occur in what? The same rates, and allometric occur in what? Different rates. Now we're going to talk about growth in plants. So I mentioned earlier that there are 3 stages of growth, which is cell division, cell differentiation, and cell elongation. So I now said only cell division when we're talking about mitosis. Now we're talking about growth in plants. So growth in plants involves 3 stages where the roots and the stem will develop. So that process, I'm going to show you the stages that are involved in that process, which is cell division, cell differentiation, and cell elongation. So what is cell division? Cell division is also called the apical meristem. That region is also called what? Apical meristem. And it involves meristematic cells that are dividing, that are undergoing what? Cell division. Come, let me tell you the meaning. When I said cell division is called what? Apical meristem region. That is, it involves what? Meristematic cells listing that are undergoing what? The cell division. So all those meristematic cells are the one responsible for what? The growth. That's it. So all those meristematic cells are the one involved in what? Cell division, are the one triggering it to what? Grow. All those meristematic cells are the one what? Responsible for actively what? Cell division. And this cell division has three parts, which is the outer parts, the middle part, and the innermost parts. And now this outer layer give birth to the piliferous layer, like the root cap and all those stuff, the piliferous layer. Then the middle layer now give birth to the endodermis and the cortex. Okay, so the innermost layer give birth to what? The pits, the vascular bundles like the xylem and phloem, etc., the pericycle. So let's look at cell elongation. What actually is cell elongation? Cell elongation is the process whereby plants take in more water, more nutrients through the help of the what? Vascular bundle. You know, the vascular bundles are the one carrying food material and liquid material, where the xylem carries water and the phloem carries food. So in the cell elongation process, that process is where they take in more water, okay, and they rise. As they take in that water, they become very large, they become very big and large and elongated. So that's cell elongation for you. The third one is cell division. So cell division is not cell division, cell maturation, or let's say cell differentiation. Cell differentiation or cell maturation is the process whereby a cell become matured. It's as simple. Even with the name, you'll be able to understand it. Even that cell elongation is only that cell division that is a little bit complex. So the region of the stems where growth is very, very fast is the apical meristem. That region, growth is very fast there. The apical meristem, growth is very, very fast there. So in the apical meristem, growths are usually very fast. Now let's talk about growth pattern. See, all the things are very, very, very easy. All these things that I'm explaining are very, very easy to understand though, but to some people it might not be easy. So let's talk about the growth pattern. Growth pattern, there are two types, which is the annual and the perennial. So the annual type of pattern is the pattern that completes their life cycle in just one phase or one stage of life. But the perennial growth have multiple stage and cycles. An example of this perennial is the aloe vera. Do you know that the aloe vera is a perennial plant? Because note this, when aloe vera dies, if aloe vera dies, it's like it can actually grow back if you water it or do anything to it that can at least stimulate growth. It will definitely grow, even if all the roots are dead. Even if all the roots are dead. That's why aloe vera plant don't die. Even if you see that it's getting black or it's getting very old and falling, aloe vera plant is not, it does not die. If you have any aloe vera plant at home that you think it's already dead or something like that, or this aloe vera, I don't know what I want to do to it, just give it time and give it the right nutrients. It will definitely grow back. Unlike plants or let's say maize plants like the corn. When you plant a corn and you have finished uprooting it and carrying the fruits that it produces, those leaves you cannot say you will water it back or plant it in the ground back. The leaves, listen carefully, the leaves, no, you cannot plant the leaves back and it will start growing, or those dead dried leaves will not grow back. No, but it's not like that in a perennial plant. Now I'm going to show you phase of growth, the curves of growth. Just two. I'm going to show you two. The annual curve shows limited growth, and the perennial crop, or let's say the perennial curve, shows unlimited growth. Let me show you where I come. Did you see the diagram there? That's a sigmoid curve. That's a sigmoid curve, and it shows limited growth. That means the growth is very, very limited. It can die at any time. The cycle can end at any time. That curve is very, very limited, and that annual pattern curve shows what? A limited type of growth. And this annual, if you can see there, you will see lag phase, exponential phase, and stationary phase. So what actually is that lag phase there? That lag phase, you see the line beneath, it's like this. It is not even moving up. You know, when any line is moving up or any pattern is moving up, you know that it's rising. So that lag phase shows that it's at its resting stage. It's planning to what? To divide, to undergo that cell division. It's planning to grow. Yes. Take a look at it very well. That lag phase it shows that it's planning to grow. And that exponential phase is actually the growth process. That's why you see the line going up. It's actually what? The growth process. That process is called the what? Exponential phase. And the stationary phase is where the plant is already trying to give up, and very soon it will surely just die or just end. The growth will just end there. It will just end there. That's why in humans, there are some certain stage you will get to, or let's say some certain age, you will stop growing. There's some certain heights females get to, and there are some certain heights males get to, and they will stop growing. So let's say, so when they give birth to a babies, their lag phase is when they are actually a baby. Think with me. No, this one I'm not teaching you here. I'm trying to give a practical example. Think with me. If they give birth to a baby, that baby will definitely be in the lag phase, right? Yes, it will definitely be in the lag phase, because from there the baby will start growing. And when the baby reach the teenage age, it will be in the exponential phase, because the baby is still growing. But when the child is like 40 years, that baby is already in the stationary phase, because it cannot grow again. Yes, it cannot grow again. That's what I'm just reasoning now, and that's very, very true. So now let's look at the perennial curve, or let's say the perennial pattern. You see there, the perennial pattern shows unlimited growth. The growth is very unlimited. You see the curve there. It's just like this, up and down, the crest and trough. I'm just using crest and trough because if you're a physics student, you know what I'm talking about. The crest and trough is just going like this, going up, unlimited growth, or let's say unlimited pattern or unlimited curve. So now let's move on to the next one. We are going to look at the factors affecting plant growth. See, I'm not going to teach you here. You are going to do a practical work for me, because this is actually what we see in our day-to-day lives. So think about it. What are the factors that can actually affect plant growth? Okay, the first one is supposed to be what? Temperature, right? Yes. If you see the weather, if the weather is too like if there is only rain, it will surely affect plant growth. The plants still need the sun for photosynthesis. Needs it to become green. It needs that chlorophyll to activate in it. Yes. So temperature affects plant growth. The second one is pH. pH is the texture, let's say the acidity of the soil. You know, when something has a high pH, it means that it's very, very basic. And when it has a low pH, it means that it's very, very acidic. So if something is very, very acidic, it can cause damage to that soil. Yes. And the third one can still be light. Plant needs light to produce, right? It needs light to grow. Very correct. It needs light to grow. Yes. So do you get all that? Plant need what? Light to grow. The other one that can still affect it is what? Water. Imagine you not watering your plant, it will die off. It will die, yes. So all those things are practical terms that we're supposed to use to think about this. Now, let's look at. Before we look at this, auxins. Auxins are one of the plant hormone, and is the plant hormone that affects plant growth. Yes, auxins affect plant growth so much. Auxins affect plant growth so much. So imagine if and auxins are found at the apical regions of that plant. That means the top of the stems and the roots. Imagine you cut it off. Let's give a practical example. So here is a plant. Cut the top of the stem out. You see that suddenly that plant will stop growing. Yes. Then bring it back, attach it together. For a while, it will drain itself the plant will drain itself, and it will start growing. Yes. Why? Because auxin was taken away, and the auxin was replaced. So if that auxin is replaced, it will grow. Yes, that's very correct. It will grow back. So auxin is the one that affects plant growth. That one, the plant hormone that affects plant growth. Even gibberellin affects it, and this auxin and gibberellin are under plant hormone. I'm especially going to treat plant hormones. I'm especially going to treat that. So auxin is one of the plant hormone that affects what? Plant growth. So let's move on to the next one. Now let's talk about the meiosis. What actually is the meiosis? Listen carefully. The meiosis is a type of cell reproduction, let's say cell division, that involves what? The joining together of two organisms. Listen carefully. Joining together of two organisms to produce a haploid number of chromosomes. Listen, in mitosis, it produces what? A diploid number. Do you know why? Because it involves one organism. Listen. It involves what? One organism. So if mitosis involves one organism, what will meiosis now involve? Two organisms, right? Yes, that is why humans, we undergo what? Meiosis division. Let's say meiosis mode of what? Reproduction. Yes, and this meiosis mode of reproduction gives birth to what? A diploid, or let's say a haploid number of chromosome. Yes, you know why? Because you know humans, we have 46 chromosome. Yes, very correct. Let me tell you how it come about. So your father has 46 and your mother has 46. When they come together, they give you, your mother give you 23 and your father give you 23. That is where any organism formed from meiosis mode of reproduction will not resemble one of them. Listen carefully. I said meiosis involve what? Sexual reproduction. We humans, we undergo meiosis mode of reproduction, abi? Yes, meiosis, meiosis, something like that. So meiosis mode of reproduction is involving what? Humans and different organisms like the animals, the dog, because it actually involves two organisms coming together. This one will bring its chromosome, this one will bring its chromosome. It will not give you chromosome. Look, your father has 46 and your mother has 46. When they come together, they'll give you what? 23 from each of them. Will not give you 23 plus 23 is what? 46. Yes, and that 46 will not give you your own chromosome. So that, because they gave you 23, that does not mean that they now have 23 left. No, they still have 46, but they gave you 23 from inside. That's in a biological terms. They give you what? 23 from inside each of them. So now give you what? 46. That is why in mitosis and asexual mode of reproduction, the parents and the daughter cells, the two identical daughter cells that are producing, is alike. They are very alike, no difference. Imagine me giving birth by what do they call it? Asexual mode of reproduction, where I'm the only one. I'm a hermaphrodite. I have both male and female reproductive system. I gave birth to another organism. It will look exactly like me, no difference. No difference at all. It will look exactly like me. But imagine when two people now come together, it cannot look exactly like you. It must have, maybe, okay, even if you don't have your physical appearance, maybe you don't have the father physical appearance, it will have the father characteristics or the father character. One nature must be inside that child. One nature, yes, must be inside that child. Yes. That is why a DNA test is even used to check if this child belongs to the father, because the father chromosome and everything is inside that child, and the mother too. So even if your mother is fat and your dad is slim, your mother is fair, your dad is dark, you will likely have either a fair nature and a slim body like your father, a fair nature like your mother and a slim body like your father, or a fat nature like your mother and a dark body like your father. You get that, right? A dark body like your father. So you will have a mixed blend. You cannot be exactly like one. So you can be fair like your mother and slim like your father, or you can be dark like your father and fat like your mother. Oh, do you understand? So that's what meiosis mode of reproduction is. You remember, mitosis involve what? Bring what? 2 daughter cells, while meiosis bring what? 4 daughter cells. And mitosis is produced by the somatic cells, while meiosis, meiosis, is what? Produced by the what? Germ cells, or you can also call them the sex cells. Yes. So the mitosis involve what? I'm waiting for you because I've said this countless times. Involve diploid number of chromosome, yes. And the what? Meiosis involve what? Haploid number of chromosome. Why? Because it involve the journey of 2 people, or the journey of okay, let's asexual mode of reproduction involves just one particular organism, and it's usually going to bring out the same organism. Yes. Example, like, okay, look at your yeast now. If yeast wants to reproduce, you think you will go and reproduce dog? No. Yeast cannot reproduce dog. No. That is why if yeast want to reproduce, you reproduce exactly like it. You will never know the difference between the mother and the daughter yeast. Oh God, all of them will just be like the same thing. Yes. But in meiosis, the mode of reproduction, like the one that human undergo, sometimes if you look at the person, you say, it's not the father that gave birth to this girl or something like that, because it involves 2 people. You cannot be exactly like that person. Yeah. So let's move on to the next one. Next one is stages of meiosis. Meiosis involves 2 stages. And the first one is what? Meiosis 1 and meiosis 2. So this meiosis 1 is relating to what? That mitosis, the mitosis stage that I give you. I gave you a mnemonic, which is IP maths. IP, interphase, prophase, metaphase, anaphase, and what? Telophase. So this meiosis 1 involves what? This one now starts from what? The prophase. So the prophase stage now involve after the prophase stage, you now see what? The metaphase, the anaphase, and the telophase. So you can use this acronym as what? PMAT. Then mitosis will be what? IPMAT. You understand what I'm trying to say? And the process are usually very, very they are very, very the same. The mitosis process and the meiosis process. I gave you the mitosis process. They are very alike. They are the same thing. Yes. But it now only involves what? Mitosis now involves what? 2 daughter cells. Meiosis now involves what? 4 daughter cells. Mitosis now involves what? Produced in the somatic cells, and meiosis now produce what? In the germ cells. So you see the contradiction there. Meiosis now involve what? Mitosis now involve what? Diploid number of chromosome, and meiosis involve what? Haploid number of chromosome. So that's just it. Now let's go to the next one. The next one that we're going to talk about is reproduction. But the type of reproduction I'm going to talk about is the what? Asexual mode of reproduction. I'm not going to talk about the sexual mode of reproduction. I'm going to talk about the sexual mode of reproduction in my next class. Yeah, I'm going to talk, not in my next class actually, in other classes, because I'm going to teach what am I going to enter? I think I will teach on the topic nutrition in my next class. But in this class I'm going to talk about asexual mode of reproduction. So there are different types of asexual mode of reproduction. I'm going to list it. So quickly, let's move on to the first one. So there are 2 types of reproduction, which is sexual and the asexual reproduction. But under the asexual reproduction, I'm going to give you the types. So the types of asexual reproduction, you will get the spore formation, the budding, the fission, the vegetative propagation, etc. Now, there are 2 types of what? Fission, which is the binary fission and the multiple fission. So the binary fission involves what? The division of an organism into 2 daughter cells. Listen carefully. So binary fission involves what? The division of an organism into 2 daughter cells, while multiple fission involves what? The division of an organism into 4, 8, 16, 32. From there, okay, 32 times 2 is not 64. You just be going like that. Imagine one organism dividing. So example of that organism that carry out what they call it, binary fusion, or let's say binary fusion is the protist, the monera. An example of the protists are the euglena, the paramecium, etc. And the multiple fission, example of the type of organism that undergo multiple fission is the plasmodium. So plasmodium undergo what? Multiple fission. Now let's look at what budding is. What actually is budding? Budding is the type of asexual mode of reproduction that involves the production of buds from one organism. Like me, I can, let's say I use myself now, I'm making an example as an organism that carry out asexual mode of reproduction. I will produce buds all over my body, and buds is like an outgrowth all over my body. You just see it swelling up here, then it will fall off. If it has what matured, it will fall off, and once it fall off, that is another organism entirely, exactly like me. You see why I say humans don't undergo this type of reproduction, because budding actually involves what? The formation of what? Buds in the body, and after it has matured, it will just fall off and produce exactly like me. Do I do like that, or do I reproduce like that? No, I don't reproduce like that, because I'm a human. So let's look at, and this budding, before we look at the next one, this budding is normally common in what? Porifera, hydra, yeast, etc. Now let's look at the spore formation. From the name spore formation, spore formation is the process of producing spore, or you can call it sporulation. Anyone you choose to, the one that you can understand and be able to remember. And this organism reproduce asexually by spore formation. An example are the algae, the protists, the fern, etc. All those reproduced by spore. The bacteria, the fungi, all those reproduced by what? Spore. Now let's look at fragmentation. When they say fragmentation, it means fragments, when they break something into fragments. Listen carefully. When I say fragmentation, is when you break things into different fragments. Yeah, you break it into fragments. Yes. So that's what fragmentation is. Now, example of those organisms that undergo fragmentation are your algae, your coleonterates, your sponges, etc. Quickly, let's look at vegetative propagation. Listen carefully. Vegetative propagation is a type of asexual mode of reproduction that involves the other part of the organism. Look, when you plant a part, or let's say a part of a plant, and it grows, and you plant that part without the seed. Look, when you want to plant a mango tree, now you definitely use the seed, or I've seen one woman, I think she used the leaf. I don't know how, I'm not sure about that, but when you want to plant mango now, you'll say you should use what? The seed. Then once the seed gets dried, you plant it and it will start growing. But vegetative propagation is not like that. Vegetative propagation does not involve the seed, it involves other parts of the body. Example are your what? Your let's say your sugarcane. The sugarcane vegetative propagation. I'm not still sure about that. Okay, let's talk about the plantain. The plantain undergo a vegetative type of propagation. Let's look at the first one, which is the bulbil. So this bulbil, let me tell you what it is. So this bulbil is a bud. This bulbil is a bud, and it's normally common, like the plant that uses bulbil as vegetative means of propagation is the bryophyllum. So the bryophyllum plant, as you can see up there, uses what? The bulbil as a means of what? Vegetative propagation. So there is a particular girl, she's my friend, and she said this leaf right here removes headache when you place it in hot fire, and when the juice is extracted and you place it on your head, it removes what? Headache. I don't know how true is that. And there is another person that said the juice, when it's extracted from this leaf, when you put it inside your mouth, it cures cough, heavy cough, it cures it. So I don't know how true is that. So the bulbil uses what? Their buds, and the bulbil serve as a means of propagation for the plant what? Bryophyllum. So now let's look at the rhizome. The rhizome grow horizontally beneath the ground. When I mean horizontally, it's like this, horizontally beneath the ground. An example of this rhizome are the ginger. Your ginger, you know ginger now, the one you use in cooking. Your ginger is example of plants that undergo vegetative mode of reproduction by using what? The rhizome. Now let's look at the runners. The runners, look at the name, the runners. They run, they spread very wide. They spread very wide. And they are the type of plant that creep above the swell, creep above the ground, on top of the swell. An example of that plant is the what? Sweet potato. Sweet potato is an example of runners. Now let's look at the suckers. The suckers are perinating organs. When I say perinating organs, like the bubule are not perinating organs. So this bubule don't have perinating organ, which is the storage organ. So the perinating organ is a storage organ that helps what? Withstand what? In unsuitable condition or suitable environment. You know, there are some environments that are not suitable for all those organisms that undergo sexual mode of reproduction. There are some environments that are not suitable for what? Reproducing. So the bubule are not perinating organ because they have buds. But these rhizome, runners, suckers, they are what? Perinating organs. So example of the suckers are the pineapple, the plantain, the banana, etc. So let's look at the combs. So these combs are underground swollen shoots that grows vertically straight like this. An example of these combs are your cocoyam, your caladium. So some people don't be like caladium is what they call it is Igbo's cocoyam. How you guys will just see some, well, maybe it's their native way of calling that particular thing or that particular cocoyam because it's slightly different from the main cocoyam. So the caladium is not called the Igbo's cocoyam. Instead, it's called what? The caladium. Yeah, the caladium. It's not the Igbo's cocoyam because it has that dot appearance on the body. They just say it's native cocoyam. No, it's called caladium. But I know the older ones, like our parents, they will not be able to, what's caladium? Just leave trying is caladium. The name is native cocoyam or Igbo's cocoyam. So that's just it for them, and for us that are actually younger than them, we are supposed to pronounce it as what? The caladium. So now let's talk about movement. That's the last thing we're going to talk about in this class today. So the first type of movement is what? Nastic movement. The second one is static movement, and the third one is what? Trophic movement. So here is what nastic movement means. Nastic movement is a non-directional movement of a part of a plant or of the plant of the part of the plant towards a stimulus. I'm going to tell you what it means. So when I say nastic movement, means a non-directional movement. A directional movement is a movement that is what? Focus, right? That is direction, that is position to go to a particular place. But this nastic movement is not like that. You can go like this, go like this, go like this. So that nastic movement is any movement to a what? To a non-directional part, or sorry, to a non-directional part of a plant towards a what? Stimulus. And the causes of this nastic movement come. Have you ever seen a plant? You know all those sunflowers that when you touch it will close by itself? That's example of nastic movement. And it's caused by what? Light intensity, tugor pressure. When you put pressure on the leaf, like touching the leaf, it will make the leaf undergo some nastic movement by closing up or something like that. And light intensity can also cause a plant to close up. There are some plants that when light is attracted to them very well, they'll just tend to move or let's say close. So all those are nastic movements. Now let's talk about tactic movement. Tactic movement is a directional movement. Let me tell you the meaning of directional movement. Directional movement is the kind of movement where the direction is positioned and you know that you're actually going there, and it's common in animals. they undergo static movements and some few plants, but it's common in animals because animals they know like they have what they are doing and they know what they are doing. Sorry, they don't have what they are doing. They know what they are doing. They know what they are doing. So when they move towards light or away from light, that's a direction movement because it's controlled by them. But plants, it's sometimes wind might shake them, light might shine too much, or somebody might just touch them, they'll just close up, like that plant that I explained. So that's what all those nasty movement, non-directional. But a tactic movement is directional. And example of this tactic movement is when animals or like euglena move away from light. That's what negative phototaxism. Movement of animals away from light or stimulus is called what? Phototaxism. So let's talk about the trophic movement. So trophic movement is the movement of plants away from stimulus. The stimulus can either be light, water, gravity. Come, I want to give you one example before I end this class. So the first example is the gravity. The gravity is pulling downwards, right? So any plant that is growing upward is what? Going against gravity, and that is what? Negative. So what is not favoring gravity is what? It's gravity's enemy. So any plant that is growing up is what? Negative what? Geotrophism. And when the plant is going downwards, what gravity actually wants, that's what? Positive. Like the roots that's going downwards, all those are undergoing what? Positive geotrophism. So we have come to the end of this class. The roles and function of parts of the cell. Like I make sure I touch different areas. Cell controls our day-to-day activities. So there is no topic we will touch that cell is not the main frontier. That cell is not the main one responsible for all those things or all those topics that I'm going to teach ahead. So we have come to the end of this class, the roles and functions, and I touched different areas that cell actually is what? The main cause of all these things. Cell is the life building block. Cell is life building block, yes. So see you guys in class. I hope you enjoyed this class. Like, subscribe for more.